All right, so in 6.1, we are trying to solve quadratic equations. Now, back in Module 3, we talked about we could solve quadratic equations by factoring. But not all polynomials can be factored, and so that leaves us with a problem. So there's got to be other ways that we can solve quadratics for those that don't factor. And so that's what we're going to be dealing with today. So we're going to talk about two other properties that will help us if something cannot be factored. Okay. So when we look at this, we're going to first talk about something called the square root property. All right. So if they're kind of in this form, where we've got, the x squared part, or you could get that x squared part by itself, that's going to make it easier for us to solve these. So we'll see things in these different forms, and that's how we're going to solve these. Okay, well, let's talk about, let's see here, that's not what I want. Not what I want either. Where is? Clicking on the wrong one there. All right, so let's fill in some things here. So whenever there's a way to do something in math, there's always a way to undo it. Every operation in math has an inverse operation. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. The inverse operation of taking the square root is squaring. All right, so squaring and square rooting undo each other. Remember, squaring means raised to the second power. Right? And taking the square root undoes that. When we take the square root, we must remember to take both the negative and the positive square roots. So here's something that we kind of have to keep in mind then on here. All right, so for any non-zero real number p, if we have something like x squared equals p, it's going to have two solutions. And those solutions are going to be square root of p and negative square root of p. So you have kind of, or sometimes we write it as a shortcut saying plus or minus square root of p. So sometimes we'll see this kind of notation with it showing both the positive and the negative. Okay, so on this first one, all right, if I'm going to use the square root property to solve this, then I need to take the square root of both sides because I'm trying to solve for x, but we've got this square. So to undo squaring, remember, I'll take the square root of both sides. So the square root and the square undo each other, just leaving x. And then the square root of 25, I've got to be really careful here because I've got to make sure I remember to put that plus or minus whenever I'm taking the square root here. Right, kind of like what I set up here, we've got to have two different answers, right, which is going to be 5 and negative 5. Now on the homework, they'll have you write it out, and that's really just to help you see those are two answers, because sometimes when students write it like this, plus or minus 5, they think it's one answer, but there's two different answers there. Okay, now I want to show you kind of the check for this, right? If I was to check the answers here, so remember I started off with x squared equals 25. So if I'm going to check x equals 5, well, if I do 5 all squared, I get 25. So that's good. Then x equals negative 5. If I do negative 5 all squared, right, that also equals 25. So I should have written it down twice there. right? So negative 5 times negative 5 is positive 25. And so both of those check out. Right? So we can, there's two different ways that we can end up with positive 25 as an answer. If we square 5 or if we square negative 5. So that's why we end up with those two answers. Okay, on the second problem here, again, this whole thing is being squared. So if that squared part is by itself, then I can just take the square root of both sides. So I'm going to take the square root here and the square root here. Now that square root and that square undo each other, just leaving x minus 3. And then here, remember that's, I'm going to write it down here and make sure it's really clear. I need to remember it's plus or minus the square root of 64. Right? And square root of 64 is 8. So let's write that down on the next one. So plus or minus 8. So this really is giving me two different equations here. I've got x minus 3 equals 8, but then I also have x minus 3 equals negative 8. And so then I need to solve these separately to figure out what x is. So let's add the 3 over. So I get x equals 11 for one of my answers. And add the 3 here, I get x equals negative 5. Okay, and again, if I check those solutions, I'll find out that both of them are good solutions. But it's always a good idea to do some checking. You don't have to check on these like you did when we solved square roots, like when they started with square roots in them. Those you have to check. These, it's just to check and make sure you did your arithmetic right and stuff. Okay, okay. One more problem like this with the square root property. Notice on this one that my x squared part is not by itself, right? I have this 3, and I've got this x plus 1 squared, and I want to just have that x plus 1 all squared. So I need to start first by dividing both sides of the equation by 3. So now that's going to give me x plus 1 all squared equals 48 divided by 3 is 16. And now I can take the square root of both sides to solve this. So the square root and the square undo each other. I'm left with x plus 1 equals plus or minus, remember, make sure you remember that plus or minus, square root of 16 is 4, so plus or minus 4. Okay. And then we can make our two equations again. X plus 1 equals 4, right, the positive 4, and then x plus 1 equals the negative 4. So let's subtract 1 over, we get x equals 3. Subtract 1 here, we get x equals negative 5. Okay. And so we get two solutions, which is what we're expecting to get, because our degree of this is a 2. And so if it was a degree of 3, we'd expect 3 solutions. If it was a degree of 4, we'd expect 4 solutions. So in this, since it's a degree of 2, we're expecting those 2 solutions. Okay. All right. Okay, so we can see from above that we can solve a quadratic equation. Quadratic just means that it has a power of 2. All right, it's all raised to a power of 2. Quadratic equation is in the form of x plus a all squared equals b. Okay. So, and we used what we call the square root property to solve the equations that are in that form. Okay, so square root property is one of the things that we're talking about in this lesson. All right, but now we're going to get into another way that we can do this and it's called completing the square. So after this one, we'll have 4 different options, right? Look to see if something can factor. If it can't factor, look to see if it's in this form. And if it's in that form, use the square root property. Right? If it's not that, then oh, sorry, yeah, then we're going to do completing the square. Next time, we'll talk about one other way that we can solve these quadratics. So right now we have 3 ways after we talk about this. Okay, so first we got to remember about perfect square trinomials. We talked about those again back in Module 3, so it may have been a little while. But a perfect square trinomial, just kind of show you some things here. All right, we're going to be figuring out what goes in this blank to make a perfect square trinomial. So to get the needed value for creating a perfect square trinomial, take half of the coefficient of the middle term, or the x term, so like this one is what I'm looking at, and square it. So on this one, all right, I take half of that middle term, so 4 divided by 2 gives me 2, and then I take the 2 and I square it, which gives me 4. All right, now it's not usually the case that we get the same number on both of those. It's just because squaring that number gives us that same thing back. Okay, let's look at this one though. So now we have negative 2 divided by, we got to do divided by 2, we're going to take half of it. So that's negative 1. Put it all in parentheses because we have to take that whole thing and square it. So negative 1 times negative 1 gives me a positive 1. So that's what goes in the blank this time. So remember, after you take half of it, put the whole thing in parentheses and square it. Okay? Because if you put this into your calculator, it would say that it's negative 1. You've got to put those parentheses around it so it knows that you want to square the whole thing and give you a positive 1. Okay, we're not going to be dealing with ones that aren't even on this, so I'm not going to have you worry about doing these guys. So those middle terms are always going to be like an even number there. Okay. All right. Now, so this is kind of the idea of what we're going to be doing with completing the square. And I have this activity here that I think would be really good for you to work through. I don't really have time today to go through it, but I'm going to post a video with this, with the video recording that I have. It kind of talks about why, because I get this from students a lot. Why is it called completing the square? And geometrically, you're going to see that we're trying to make, a square on here. And that's what's happening. We're completing the square, making sure that we can see what that is as a whole square. Okay, but I'm just going to get down here to these parts of like how to solve by completing the square. So on our homework, and in this one, our coefficient of the x squared term is always going to be 1. Now, if you take 1050 after this, they're going to show you what to do if that coefficient isn't 1. Okay, but on our homework, it will always be 1, so you don't have to worry about that. All right, and then you want to make sure you get all terms, everything on one side of the equation and put the other side equal to 0. And then this is where we do that thing that I talked about above, right? Take half of the coefficient of the x term and square it. That's the completing the square part. And then you're going to add that to both sides of the equation. And then we're going to use the square root property after we factor it. Okay, so looking at these, actually this is talking about one of the ones that's up above, this that problem 7. So I'm going to show you algebraically how to do this here. But again, watch that other video that I give you, and it will kind of make more sense geometrically what's happening here. Okay, so first thing we need to do is we need to subtract the 12 over to the other side. All right, so I get x squared plus 8x, and then I'm going to put in some blanks here because we're going to be filling in some blanks. So I'm going to say plus blank, all right, and then equals negative 12, because I moved that over to the other side, and then plus another blank. So I've got to find what makes this a perfect square trinomial, and then I will add that same number to both sides. So again, remember that the steps to that is we're going to take half of the middle term, so we'll take 8, divide it by 2, we get 4, take 4 and square it, we get 16. So 16 is what we're going to put in both of those blanks. Actually, maybe I should have put this over here as some side work, so it's easier to see. What we're going to do on this next stuff here. Okay, so now we've got this perfect square trinomial, and we need to factor that. And remember, these factor nicely when it's perfect square trinomial. We're thinking, what multiplies to be 16 that adds to be 8? Well, that's going to be a positive 4 and a positive 4. So x plus 4 times x plus 4. But to simplify that more, that really is x plus 4 all squared. Okay, now let's simplify the other side. Negative 12 plus 16 is positive 4. All right, now this looks like what we had above when we talked about the square root property. We have on this one side, right, the only thing that's there, this whole side is squared. So now I can take the square root of both sides to be able to solve this. So that is gone, leaving x plus 4 inside. So I've got x plus 4 on the left equals, now be careful here, remember, when we do this, taking the square root of it, it's not just, square root of 4 is not just 2, we need the positive and the negative, so plus or minus 2. And then write those two out, x plus 4 equals positive 2, x plus 4 equals negative 2. And let's subtract those over, so x equals negative 2 is a solution, and x equals negative 6 is the other solution. So x equals negative 2 or negative 6. And those would be your answers. So again, the biggest part to remember on here is that, remember, we have to take half of the middle term and square it. Okay, so on this one, we already have that constant term already on that side of the equation, so that's good. All right, so now I just need to kind of put some blanks in here. So I'm going to have it as x squared plus 6x plus blank. And I've got to figure out what is that like magic number that I need to add there to make that a perfect square trinomial. And whatever it is there, I've got to add it to both sides. Okay, so let's do a little side work. So we're looking at that 6 in the middle. So I take 6 and I divide it by 2. I get 3. And then I take 3 and I square it to get 9. So 9 is what I end up with inside. Okay, now let's factor this. All right, and so remember the shortcut to factoring this, when he said, what multiplies to be 9 that adds to be 6? Well, it's the same number, it's 3, so we're going to write it as x plus 3 all squared. And then that equals 0 on this one. Okay, let's take the square root of both sides. So we can do this. Right, so I get x plus 3 equals, now 0, remember, doesn't carry a sign, so on this one we won't put plus or minus 0, it's just 0. And then we'll subtract the 3 over, so x equals negative 3. On this one we only end up with one solution. Okay, and part of this that's going to happen, I mean, again, I'd like you to click on this link and see what happens to this, because the graph of it's kind of interesting. It's just showing, I mean, when you do this, so at negative 3, our parabola is just touching right there at negative 3. It's not crossing like it would be on this one. This one, it's crossing the x-axis at negative 2 and negative 6. But on this one, it's just touching right there. The vertex of the parabola is there. Okay. All right, let's go down and do just a couple more here, and then we will be done. So let's solve this by completing the square. So again, our first step, let's start by moving that constant term over. So I get x squared plus 8x plus blank equals positive 3 plus blank. Now it's always going to be a plus, because remember, a negative times a negative is a positive times a positive is a positive, and we're always multiplying that the same number, we're squaring it. Okay, so let's take half of the middle term, so 8 divided by 2 is 4, and then square it, we're left with 16. So 16 is what goes in my blank on these. All right, now this is going to factor to be x plus 4. It's always going to be what we find it, half of that middle term to be. Whatever half of 8 is, it's 4. So plus 4 all squared equals 3 plus 16 is 19. All right, and now we got to square both sides so we can solve this. Or sorry, not square root both sides. So here, those undo each other. We're just left with x plus 4 equals not just the square root of 19, but plus or minus the square root of 19. Right? And then to get my x by itself, I need to subtract the 4 over. Now, square root of 19 doesn't simplify. It's not a perfect square. And so before, these ended up being a perfect square, so I wrote out the 2 separate equations. But on this you won't have to. But when you subtract that 4 over, put it in front of your plus or minus sign. So I've got x equals negative 4 plus or minus the square root of 19. And that whole thing is your answer. And again, there's 2 solutions, right? Negative 4 plus square root of 19, negative 4 minus square root of 19. Okay, so 2 solutions there. All right, one more here to look at. So again, we'll start by subtracting that 15 over x squared minus 6x, and then we're going to put plus blank equals negative 15 plus blank. All right, so in this one, now we're taking negative 6 and halving it, right? Negative 6 divided by 2 is negative 3, and then negative 3 all squared. Negative 3 times negative 3 is positive 9. So I've got to add 9 to both sides here. Okay, now on here, let's factor that. It's a perfect square trinomial, so easy to factor. X minus 3, whatever half of that middle term is, all squared, equals, now I've got negative 15 minus 9. Right, I'm going to end up with a negative number here. I'm going to have a negative 6. Right? Negative 15 plus 9 is negative 6. And so now when I take the square root of both sides, all right, I get something kind of different that happens here. On the left side, that's pretty much what we've done before. That becomes just x minus 3. But here, I've got a square root of a negative number. So I've got to change this to I. But again, I need to make sure I put that plus or minus sign. All right, so the square root of negative 1 is I. So plus or minus I. And then square root of 6. Square root of 6 can't simplify anymore because there's not 2 of the same factors in there. And then all that's left to do to get x by itself is add the 3 over. And again, remember to add that in front of your plus or minus sign. So I get x equals 3 plus or minus I square root of 6. And those are your solutions, right? So we end up with negative, or we end up with imaginary solutions on some of these. Okay? And what's happening when we end up with imaginary solutions, if we were to graph it, we actually, I call it a hanging parabola. So it's kind of like this. It never crosses the x-axis anywhere. So it's either like, right side up and above the x-axis, or it's upside down and below the x-axis. It never crosses the x-axis. That's why we end up with these imaginary solutions. All right. Okay, thank you guys so much for joining me today. And that